In this example, we have assumed that the surface of the Earth is a sphere with radius 3,963.2 miles, which completes one revolution about its axis in approximately 24 hours. Knowing that Salt Lake City is 40 degrees and 45 minutes, or 40.75 degrees north latitude, and 111 degrees and 53 minutes, or 111.8833 degrees west latitude, what is the average linear velocity of a person sitting on a bench in Salt Lake City, round to the nearest whole number? So, if we think about the Earth as a sphere in this case, something like this. If we were sitting on the equator, then that means that we would be sitting on a plane of revolution. We'd be sitting on a circle of revolution that has a radius of 3,963 miles. However, we are sitting about 40.75 degrees north latitude. So we are sitting about 40 degrees north of this. And in Salt Lake City, that means that we are sitting on a circle of revolution that is not as wide as it is on the equator. Meaning, what we need to find is what is the radius of revolution on the circle that Salt Lake City sits upon. In order to find that, essentially what we need for our situation in Salt Lake City is we need to find the x value associated with the triangle made by 40 degrees 0.75 north latitude. So, if we just think about this as just a triangle here. If I zoom in on this, I'm trying to just think about this as a triangle that has an angle measure of 40.75. And I want to find the x value so that I know what radius of a circle we are sitting upon. Well, we know the hypotenuse side here because the distance out to the edge of the circle at all is the same as the radius of the sphere, which is 3,963 miles. So, if I know that angle measure, I want to find x, and I know the hypotenuse, this means I should be using cosine. If I use cosine of 40.75 degrees, I can define that as the adjacent over the hypotenuse. Or that x is equal to the hypotenuse times cosine of our angle measure. This will give us our amount of miles. This will give us our radius in miles. Because I want to find the average linear velocity, I need to find that amount of distance in the certain amount of time. This radius of the circle that we sit upon can help us determine what the speed is of the revolution. Because if I use the formula for average angular velocity, I will scroll this down a little bit for. Average angular velocity is what happens when you take r times theta over t. In this case, we now know what r is. This is r on the circle that we sit upon. Theta in one full revolution is 2 pi, and the time it takes to do that is 24 hours. So our average angular velocity is 3963.2 times cosine of 40.75 degrees. That is the radius times the rotation degree, or the rotation angle measure. This is 2 pi for one full rotation, divided by time, which is 24 hours. This will find our approximate velocity in miles per hour. So let's use a calculator to approximate that. If I take 3963.2 times cosine of, in this case, I do need to make sure I am in the correct mode. I am in degree mode. So 3963.2 times cosine of our degree measure, 40.75. I will multiply that by 2 pi. Do not worry about the mode messing that up because 2 pi is not within a trig function. Divided by 24 hours. That gives me, rounded to the nearest whole number, 786 miles per hour.